All right. He comes back to a post quick. All right. Today, Unit 5, Lesson 1, Investigation 3, we are going to factor quadratic equations with the special cases. All right. So special cases for factoring quadratic equations, there's two types. The first one is factoring out common terms. The second one is difference in squares. All right. Now, first one, factoring out common terms. If I look at this, okay, sometimes your book will say, factor these equations. They'll give you something like this, x squared plus 4x. Is that something we've factored before? Yeah. Yeah? In the past week, we haven't, have we? This is a lot different. We factored ones like this, haven't we, with 3 terms? Now, when there's only 2 terms, okay, it is easier than when there's 3. When there's 2 terms like this, where they both have an x in them, we just find a common term that's in both. Okay? We find something that's a common factor to both. So, looking at this one, x squared plus 4x. What's a common factor in both? X. So, to factor this one, we just take an x out of each term. Okay, we divide each term by x. Alright? So, I write an x out front. I divide that by x. What's x squared divide x? X. What's 4x divide x?
4x squared.
4. Okay?
4.
Think about it this way. It's 4x divide x, right?
Yes.
So then the x's cancel out. Alright, so it's just 4. Right? So now this right here is the factored version of x squared plus 4x. Okay? Pretty simple? Yeah. Now, this is still a parabola, right? These are still our intercepts. This m value is 0. This n value is -4. X is x minus 4, right? Or x plus 4, sorry. Usually it's x minus n. Right? Alright. Try this one on your own. 3x squared minus 9x. Okay, real quick. Look for the common term. 3x squared minus 9x. Try it on your own. All right, gentlemen. Think you know what the common term is?
Yeah.
What is it, Michael?
3x.
3x. Anybody disagree with Michael?
I do.
You do? All right, Jared. All right. So 3x is our common term, right?
Yeah.
So if I divide this 3x squared by 3x, what do I get?
X.
Just x. So we're factoring out the 3x. So we have x. Now, 9 divided by 3x, what's that? 3. So I factored this one. Okay. My m value is still 0, and my n is 3. Okay. So it's just as useful as the other forms. Right. Does this make sense, guys? Okay. Now we can only do this when both terms have an x. Okay. If you look over there, which is later on, only one term has an x, and we'll get to that in a little bit. Okay. Well, I guess you could also do this if there's no x squared, which is x plus 4. Or 2x plus 4, you can do it. All right. But we only factor this way when we have an x squared and an x. Okay. All right. The next one. Have we factored something like this before? Yeah. It's kind of what we started out with today, isn't it? What we did yesterday. All right. Now, if I was going to factor this one like we did yesterday, we're going to have to look at the factors of 4 and the factors of 20, right? Right. What are the factors of 4? 2 and 2, 1 and 4. Each of them has an x, right? So 2x and 2x, 1x and 4x. What's the factors of 20?
5 and 4, 1 and 20, and 2 and 10.
Okay, good. 5 and 4, 1 and 20, and 2 and 10. Now, there were 2 factors of 4 and 3 factors of 20. So there's a chance that I could try this 12 times before getting the answer, isn't there?
Yeah.
Right? This one might take us a long time, right? Right? Now, factoring out the common term, that can help us here too. Okay? If I look at all 3 of these numbers, okay, you'll notice they're all even, but there's a common term. What is it? 4. I can take a 4 out of each of these. Right? So then we have 4 What does this become? X squared. 6x. 5. Okay. Now I took one where a was 4, and I turned it into a situation where a is 1. Which one's easier to factor? The 4x squared one or the x squared one?
X squared.
The x squared. The bottom one's easier to factor, isn't it?
Yeah.
Yeah. So by factoring out that 4, I took a might have been difficult problem and turned it into a fairly easy one. Right? Now if we factor this, you'll see it is a pretty easy factorable problem. So x squared and 5, what's the factors of x squared? X and x. 5 and 1, 5 is prime, so there's only one factor, right?
Yeah.
This one's going to be real simple. So x times 5 plus x times 1. X times 5 is 5. X plus x times 1 is, add them together, we get that 6x, don't we? Yeah. So that means my factors, after we cross over, right? Drop down and cross over. Right, my factors are x plus 1 and x plus 5. Now, are these the factors of the whole thing? No. They're just the factors of my x squared plus 6x plus 5, right? So what do I have to do with that 4?
Bring it down.
Bring it down. This 4 comes back out front. So then that's, right, 4 times x plus 1 times x plus 5 is the factor version of this. Right? I would advise you, anytime you can take a number out before you start factoring, I would do it. Because it makes the problem a lot easier. Okay? Takes what might take you 10 minutes to factor and turns into something that might take you 3 minutes to factor. Right? Takes a problem that you might consider too much, right? And turns into one that's kind of the ones we done the first day.
Not too much.
Yeah, not too much. Now it's just enough, right? Does that make sense, guys?
Yeah.
Okay. Explain it again. Want to try another one? Yeah. Okay. Let's try. Oh. 6x squared plus 18x plus 12. Okay. 6x squared plus 18x plus 12. All right. Now, if I look at that, what's a common term? What is it?
6. 4.
Okay. There's a couple, right? 2 is a common term, right? 3 is a common term.
Use the highest one.
Use the highest one. The highest one's going to make it easiest because every time you make these numbers smaller, you make less and less factors, don't you? All right? If I can get this down to 1 in front, I want to. All right? So what's our biggest common factor? 6. So I'm going to pull that 6 out front. So I'm write 6 times x squared plus 3x plus 2. Right? So now, Erica, now instead of factoring this where a is equal to 6, I'm factoring this where a is equal to 1. Right? Does that make sense? Why is the number in front? Because each of these had a 6 in them. So I pulled that common factor of 6 out. Okay? Just like we did over here where each of them had an x, we pulled that x out. Okay? So each of them had a 6 in it, so we pulled that 6 out and then left the remaining factor there. So 6 divided by 6 is 1, right? So I have 1x squared. 18 divided by 6 is 3. 12 divided by 6 is 2. How do I finish it? Now I just factor this, x squared plus 3x plus 2. So the factors of x squared, x and x, right?
Okay, then you just do it and then you just pull the 6 down.
Yep, 2 and 1. Yep. Then once we write these factors, we pull the 6 down.
Oh, okay.
So I'll finish this up just to be complete. So x times 1 plus x times 2, which equals 3x. So my factors are x plus 2, x plus 1, and the 6 comes down right there. So this is my factor version. All right, does that make better sense now?
Yeah.
Yeah. Are there any questions about either one of those? Any questions about either one of those? No? All right. So factoring out common terms, if you can, do it. All right, makes the problems a lot easier. All right. The first ones, in order to factor, you have to take out the common terms. These ones you can factor without taking the common terms out, but it's going to take you a lot longer. So if you can take a common term out, then that's a good idea. Now the last special case is what's called the difference of squares. Right? Hopefully the name gives it away. Okay? The difference of squares. Okay? Now, if I'm going to factor this, I have my a term, right? Ax squared. I have my c term, 16. Right? What term am I missing? B. So if my b is gone, that means my b is what? 0. So I could rewrite this as 9x squared plus 0x minus 16. Right? Does that seem plausible? Yeah. Now, can I factor this like normal?
Yeah.
Yeah. We can do 9x squared, 16. Oh, negative 16. Almost forgot. What's the factors of 9x squared? 3x, 3x, 1x, 9x. Anything else? Nope. What's the factors of negative 16? Remember, the 16 is negative, so each group must have one negative, right?
1 and negative 16.
Okay, so 1, 4, and negative 4.
Negative 4 and 4.
Okay. Negative 8 and 2 as well.
Negative.
Negative 1 and 16, right? So those are all our factors of negative 16. Right?
Yeah.
Now we want this middle term to be 0, right? Now we could go through and try all these possibilities, but if you think a little about think a little bit in advance, or kind of think ahead a little bit, if I want that middle term to be 0, then which factors of 9 should I use? 3 and 3. Which factors of 16 should I use? 4 and 4. Okay? So let's try that out. Let's see if we're right. So 3x times 4 plus 3x times negative 4. 12, right? Negative 12? Does that equal 0? Yeah. So we found it, right? So then when I factor this, we get 3x minus 4. We're dropping down on the crossing over. I'm going to draw my two parentheses first. So we get 3x plus 4. Right? Correct? Now this is called a special case, not because you had to remember the 0, but because there's a shortcut. Okay? Now you guys who are taking notes, like there's a shortcut, and I just wrote all this down. Right? I remember those days too. All right. So 3x minus 4 times 3x plus 4. There's a shortcut there. All right. Let's look at the name. Difference of squares. Is it talking about the geometric figure with 4 sides? No, it's talking about what? Squared numbers or square roots, right? Right? How does this 9 relate to that 3? 3 squared is 9, or the square root of 9 is 3, right? How does this 16 relate to that 4? Square root it, right? 4 squared is 16, square root of 16 is 4, right? That's where the difference of squares comes in, right? Anytime something is written of this form, all right, where it's a number squared times x squared minus another number squared, there's a shortcut we can use, right? So would you guys agree that this fits the form ax squared minus, a squared x squared minus b squared? Would you guys agree it fits that form? Yeah, because 9 is what number squared? 3. 16 is what number squared? 4. So this one right here is like having 3 squared x squared minus 4 squared, right? Would you guys agree with that? All right. So that means since it fits this form, I can use my shortcut that gives me 2 factors that look like these ones down here. Okay? What do you guys think these 2 factors are? Well, it goes 3x minus 4, 3x plus 4. So what's it going to be in a more general case when I'm using a and b?
Ax minus b, ax plus b.
Good. Ax minus b, ax plus b. So anytime I have something that fits this format, a squared, x squared minus b squared, I can use that shortcut and write ax minus b times ax plus b. Now this is the only shortcut in factoring. Only one. Okay, there's no other shortcuts. There's no calculator stuff, Christian. All right? Only shortcut in factoring. And this only works if this sign right here is what?
Minus.
Minus. Okay? If that's a plus sign in there, it won't work. It has to be a minus sign. All right, that's why it's called a difference of squares. Are there any questions about that? You guys want to try one of those on your own?
Sure.
Sure? Okay. Let's do 25x squared minus 81.
5 and
Okay. Michael, you're ruining everybody else's fun.
9.
25x squared minus 81.
Looking forward to factoring that. You know you were.
Okay, try it out. Take a little bit.
Michael already did.
He didn't finish it for you though. He just told you the number.
Oh, you want to finish?
Don't help Michael. You can help Travis, but not Jared.
Aw. I don't want to.
Jared, I can help you.
There you go. The square root of 20. Yeah. Yeah. Where did she get 1 and 9?
What?
I told you. She said 1 and 9.
1 and 9?
She said 1 and 9.
Sound like 5 to me.
She said 1.
Easy? Good.
How is it not?
I said
Shortcut. Shortcut. Yep. Think about what's the square root of 25? What's the square root of 81? 9. So what's your A? 5. What's your B? 9. So wherever you see an A and a B, great. 5 for A and B.
5.
Yeah. So then that sets us up with the A squared x squared minus B squared. So then we can rewrite it with the factors. By putting the 1 in for the A. 5 and 1 for the B. Perfect. All right, guys. Sounds like we're done. So 25x squared minus 81. What's the square root of 25? 5. What's the square root of 81? 9. So that means in this, A is 5, B is 9. So this factored is 5x minus 9 times 5x plus 9. Right? Any questions? Questions? All right. Nice job, everybody.